Hello, my name is Alan, and I'm here with Pat, Eric, and Andy for our senior design project with L&S Machine Company. L&S Machine Company has a background in machining, welding, and inspection with a specialty in commercial nuclear reactors. They are ISO 9000 and 9001 certified, and they have over 20 CNC machines on their factory floor. The problem L&S currently has is that their CNC machines are collecting data that have extreme outliers, which adversely affects their operations. With these outliers present, L&S cannot accurately find nominal times for the parts. However, L&S also has no way to filter out these bad data points while keeping good data points intact.
Initially, when tasked with the problem, L&S mentioned that they believed that the outliers were caused by employees pausing the machine at their shift end, which caused the timer to remain counting. After our detailed root cause analysis, we discovered a few more specific causes of these outliers, and they were software limitations with the pause button not actually pausing the time, rework time, and the changing priority when a more important order comes in. In order to achieve these results, our team needed to fully understand the data and process. To do so, we completed multiple Gemba walks during our different visits to the facility. We also interviewed several operators as well as Lauren, L&S's IE, and their CEO, Rob Donardi. The walks and interviews gave us a complete knowledge of the process and its limitations. Going forward, our plan was to develop an Excel tool to be able to eliminate the bad data points. The goal here is to differentiate between those bad points and leave in the good points that are within reason or explainable. Then this tool will be able to use all of the corrected data for its outputs shown on the next slide.
Our first deliverable is an Excel function that filters out irregular data points. The function takes the data and determines if each point can be finished before the next shift end. If not, the point is filtered out and unused when analyzing data. The user can also choose a tolerance to define what they consider to be a bad data point, allowing for more flexibility in data analysis. As shown in the graphs, there are still multiple times where parts should have been finished on time and instead took over 1,000 minutes to complete. In addition, we can see how irregular data points skewed the average cycle time for the part. In our unfiltered data, cycle time is thought to be 375 minutes, but after filtering out the points that were doomed to failure, we see our average cycle time drops to 320 minutes, almost an hour less. Currently, L&S does not use the data that they are collecting on cycle times. Our next tool will allow L&S to analyze the data in a useful way. This is the Worker Performance tool. It allows for the user to sort by machine, part, and operation number, as well as good and bad data points. The tool then outputs the average cycle time, percent finished, and other useful information for each operator. This can be used as a tool for L&S to determine which operators may need additional training. It is also a quick way for L&S to analyze other operator statistics as needed.
For our other deliverables, we wanted to leave them with some possible recommendations for improvement. Although we didn't have the time to implement these improvements, we created a guide on how to easily implement them while also explaining the benefits behind the recommendations. We offered a total of 6 suggestions, such as creating a priority system and standardizing their machine speeds. We also provided them with visual work instructions on how to use our tool in Excel. Although not an entirely difficult tool to understand, providing easy to follow work instructions will prove valuable to anyone trying to utilize our tool.
In order to make sure we were working towards our goals, we created a few metrics to follow and measure. These ensure we were driving improvements. Our first metric was dollars saved based on shop time. We used an hourly cost for shop floor time at $80 an hour. If our employee tracking was used to find the best methods, we estimate that over the last year, L&S could have saved $4,183 by training on this specific part. Another metric we wanted to look at was number of root causes solved. After doing a small analysis, we estimate that we solved 80% of the total root analysis causes. We finally looked at how many bad points were eliminated on a specific part and machine, which we found to be 30 for the part shown.
Finally, we want to thank Rob and Lauren from L&S for all their help throughout the semester. And we'd also like to thank Dr. Haight for all his insight and willingness to help us, as well as Dr. Sakery through guiding us through our senior projects.